Good morning students. I welcome you in today's session of physics, and in today's class I am going to present you your topic of heat, which is your calorimetry. Fine. So today we will discuss about what is calorimetry. In this chapter you have to study about the specific heat capacity, principal methods, mixtures, problem on specific heat capacity using heat loss and gain, and methods of mixtures. Here you can see this is the syllabus you have to cover out in this chapter. Fine. So firstly we will start with the concept of heat and temperature. Here you can see this is the topic we have to take today. So let's start it. Concept of heat and temperature. We know that each substance is made of molecules. The molecules is a substance are in a state of random motion. I hope you are familiar with the random motion. The molecules of the gas particles, when we provide external heat, they started doing the motions. Fine. So the motion of that gas particles is considered to be the random motion, or you can also say that the zigzag motion. Fine. So the kinetic energy due to random motion of a molecule of a substance is known as heat energy. So how will you define the heat energy? You can define it, the kinetic energy due to the random motion of molecule of a substance is known as its heat energy. Here is the definition, you have to remember it. Fine. Thus a body possesses heat energy in the form of its internal kinetic energy. Clear? When some quantity of heat is supplied to a body, the random molecular motion increases. Means if you supply some external heat over a body, the random molecular motions, fine, is increases, which results in the increase in temperature. So when the molecular random motion of the molecules increases, it causes to the increase in the temperature of the body. I hope it is clear. Similarly, if some quantity of heat is removed, or you can say withdraw from a body, its random motion of the molecules is decreases and the temperature of the body fall. Clear? Here you can see a definition is written there. The average kinetic energy of the molecule of a substance is a measure of temperature of that substance. Here you can see this is the definition of the average internal kinetic energy of the molecules of a substance. When two bodies at different temperature are kept in contact, you can see here, if you put two bodies of different temperature, suppose the first body is at a lower temperature and the another body which you kept in contact with the first body is at a higher temperature, then what will happen? Heat flow from the body at a higher temperature to the body at a lower temperature. Fine. This is the temperature which determines the direction of flow of heat. I hope it is clear. Now you can see here, like all the forms of energy, heat is also a measurable quantity. Means you can measure the heat also. The measurement of the quantity of heat is known as calorimetry. So what is calorimetry? The measurement of the quantity of heat, means how much quantity of heat you are given to a body, is known as the calorimetry. Now we will discuss about the unit of heat. Here you can see, like other form of energy, the SI unit of heat is also what is joule, and you represent it with the symbol capital J. The other most commonly used unit of heat is calorie. Here you can see the other unit is calorie. And what is the relation between the joule and calorie? 1 calorie is equals to 4.2 joule. Fine. So it is defined as follow. 1 calorie is the heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. Means if you take 1 gram of water, fine, and you are giving the heat so that its temperature rises to 1 degree Celsius, then you can say that 1 calorie is heat we have given to the body. So this is the definition of calorie. Clear? Now you can see here in this definition of calorie, it has been assumed that the heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius at initial temperature is the same. However, this is not due to the non-uniform thermal expansion of water. Hence the correct definition of calorie, which is also called the 15 degree Celsius calorie, is given as follow. You can see here in this bracket written here, 1 calorie of heat is the energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius, means there is an increase of 0.1 degree or 1 degree Celsius over there. The unit of calorie is related to the SI unit of joule. As I told you, the 1 calorie is equals to how much? 4.186 joule, or approximately you can write it 4.2 joule nearly. Sometimes calorie is a smaller unit of heat, so we use bigger unit called like the kilocalorie. Fine. So 1 kilocalorie equals to how much? 1000 calorie, or nearly you can write it 1400 joule nearly. So 1 kilocalorie of a heat is the energy required to raise the temperature of 1 kg of water from 14.5 degrees Celsius to 15.5 degrees Celsius. You can see this is the exact definition of calorie, 1 kilocalorie. Now, the unit of kilocalorie is generally used for measuring the energy value of food, means how much calorie you have eaten in the food, how much calorie you gain. So you can see here there is a difference between the heat and temperature. This is the important thing you have to remember, what is the difference between heat and temperature. So as you can see here, the first one is the kinetic energy due to the random motion of the molecule of a substance is known as Heat's energy. Fine. When the particle or a molecule takes random motion, then it is considered to be a heat energy. Now what is the temperature? The quantity which determines the direction of flow of heat between two bodies which are kept in contact is known as temperature. Here you can see this is the difference between heat and temperature. Now move to the second one. The SI unit of heat is joule and the SI unit of temperature is how much? Kelvin. It is measured by the principle of calorimetry. How will you measure the heat? You will measure the heat by the principle of calorimetry. And how you measure the temperature? It is measured by a thermometer. The fourth one, it is an additive quantity and it is not an additive quantity. Clear? Now here we will discuss about the factors affecting the quantity of heat required to raise the temperature of a body. This is the thing we have to discuss right now. The quantity of heat energy required to raise the temperature of a body depends on three factors. Now you have to remember on what factor the heat energy which raising the temperature is dependent. So they are dependent on the three factors. The first one is the mass of the body. Clear? The second one is the nature of the material or the substance of the body, means at what material you have taken so that it conducts the heat. Now the third one is the rise in temperature of the body. How much rise there is when you supply over a heat over the body, then what is the change in the temperature or what is the rise? Clear? Now experimentally it is found that different masses of same substance, here you can see different masses of the same substances require different amount of heat energy to raise their temperature by the same amount. Clear? It means that if you suppose take a rod of iron which has a mass of 5 grams and another rod you have taken of copper, it is also mass of 5 grams. But the amount of heat you have given to raise the temperature of iron and the copper is totally different. Clear? So that is the thing is written here. The amount of heat energy required is found to be directly proportional to the mass of the substance. Fine. So here you can see delta Q is the change in heat, you can also say that is proportional to the mass. Fine. Here is a symbol before the delta Q, you can see that it denotes the change in the quantity and is read as delta. Clear? Equal masses of different substances require different amount of heat energy to raise their temperature by the same amount. That is thing I have already told you that if you take a iron and the copper rod, then you have to supply different amount of heat to raise their temperature. For example, if equal masses of water and the copper are heated through 1 degree Celsius, so the amount of heat required for the water is 10 times more than the required for copper. Clear? Thus, the amount of heat energy required depend on the nature or you can say the characteristic substance, and it is expressed in terms of its specific heat capacity, which is your C. This is small c. Clear? It is not a speed of light. This is specific heat capacity. Now the third one is equal masses of the same substance requires different amount of heat energy to raise their temperature by different amounts. Here it is written that the amount of heat energy required found to be directly proportional to the rise in temperature, that is Q is directly proportional to how much? Delta T. Here delta Q is proportional to the delta T. So from the above, first one we have already proved here, delta Q is proportional to the mass, this one from here, and another one we have found it here, delta Q is proportional to the delta T. So from those both the relation, if we combine together, so how much we will get here? We will get here delta Q is equals to C times of M delta T, or you can also say that delta Q equals to MC delta T, where C is your specific heat capacity, M is the mass of the substance, and delta T is the rise in the temperature. Clear? You can see here C is the constant of proportionality, which is also called as the specific heat capacity of the substance. I hope it is clear. Now we will discuss about the thermal or the heat capacity C dash equals to delta Q by delta T. This is the topic we are going to discuss right now. So from our everyday experience, we find that here you can see that this thing we have to discuss now. Find that different bodies require different amount of heat energy for equal rise in their temperature. Clear? This property of a body is expressed in terms of its thermal or heat capacity. So how will you define the heat capacity of a body? Is determined as follow. The heat capacity of a body is the amount of heat energy required to raise the temperature by 1 degree Celsius or 1 Kelvin. Clear? It is denoted by the symbol. By which symbol we will denote it? We denote it by the symbol C dash. So you can write it, heat capacity C dash is equals to amount of heat energy supply divided by the rise in temperature. So if on imparting delta Q amount of heat to a body, its temperature rises through T degree Celsius, or you can say that T Kelvin. In that case, heat capacity of the body, that is C dash, is equals to delta Q by delta T. Fine. Now we know that the size of a degree is same as on the Celsius and the Kelvin scale. So the changes in temperature has same magnitude in degree Celsius and in Kelvin. So you can write it, the relation like this, delta T is equals to delta T Kelvin. Clear? In other words, 1 degree Celsius rise in temperature is same as 1 Kelvin rise in temperature. So if the heat capacity of a vessel is 30 joule per Kelvin, it means that the heat energy required to raise the temperature of the vessel by 1 Kelvin or 1 degree Celsius is how much? 30 joule. I hope it is clear. Now we will come to the unit of heat capacity. You can see here, this is the whole thing we have to discuss now. So SI unit of heat capacity is joule, as I told you earlier, per Kelvin. It is also written as joule per degree Celsius. Since 1 Kelvin rise in temperature is the same as 1 degree Celsius rise in temperature. The other common units of heat capacity are calorie, kilocalorie, and they are related as, you can see the relations between 1 kilocalorie degree Celsius per degree Celsius equals to how much? 1000 calorie per degree Celsius, and 1 calorie per Kelvin equals to 4.2 joule per Kelvin. This is the relation between kilocalorie per degree Celsius and calorie per Kelvin. I hope it is clear for you. Now we will come to the point of number 11.3. This is specific heat capacity. How will you define the specific heat capacity? So heat capacity of a body when expressed from unit mass. Clear? Here you can see, when we divide the heat capacity of a body with its unit mass, it is denoted, then it is called as specific heat capacity, and it is denoted by the symbol small c. Thus, the specific heat capacity of a substance or a body is defined as the heat capacity per unit mass of that body. So you can write it, the formula here you can see that specific heat capacity is equals to heat capacity of a body upon mass of the body, or in place of C you can write specific heat capacity, you can write small c is equals to heat capacity of the body is how much? C dash, and mass of the body is M. So after solving this relation, you will get here C dash is equals to MC. What is C dash? C dash is your heat capacity equals to mass into specific heat capacity. This is the relation between heat capacity and specific heat capacity. I hope it is clear. So from the above equation here you can see, this is equation number 11.4, relates the heat capacity of a body to the specific heat capacity of its material. In other words, we can define a specific heat capacity as follow. You can also define specific heat capacity. The specific heat capacity of a substance is the amount of heat energy required to raise the temperature of the unit mass of a substance from 1 degree Celsius or 1 Kelvin. Clear? That is, the specific heat capacity is equals to how much? C is equals to amount of heat energy supply upon mass into rising temperature. I hope it is clear. So, if on imparting delta Q amount of heat energy to a body of mass is small m, its temperature rises to how much? T degree Celsius, delta T degree Celsius or delta T Kelvin. Then its specific heat capacity is given by which formula? C is equals to delta Q by m delta T. If the specific heat capacity of a substance is 1.6 joule per gram per Kelvin, it means that the heat energy required to raise the temperature of 1 gram of the substance by 1 Kelvin or 1 degree Celsius is 1.6 joule. So, this is your equation number 11.5, and from this equation, heat energy required to raise the temperature of a body of mass m kg by delta T Kelvin is given as by this formula. Delta Q is equals to m C delta T joule. I hope it is clear. Now we will come to the unit of a specific heat capacity. We will discuss about the unit. So, the SI unit of heat capacity is joule per kilogram per Kelvin. You can see here, this is the unit. It is also written as joule per kilogram per degree Celsius, or you can also write like this. So, 1 degree Celsius rise in temperature is the same as 1 Kelvin rise in temperature. The other units of specific heat capacity are calorie per gram per degree Celsius and kilocalorie per kg per degree Celsius. These units are related as follow: 1 calorie per gram per degree Celsius is equals to how much? 1 kilocalorie per kg per Kelvin, or in place of kilocalorie you can write here 4.2 into 10 to the power 3 joule per kg per Kelvin. Clear? So, this is the unit of specific heat capacity. So, for today's class I end this session, and for the remaining topics we will cover in our next lecture. Till that, do study. Thank you class. Thank you very much.